AP Style Free Response Problem 8. Use the provided graphs to determine A, the order of the reaction with respect to ethanol. Justify your answer. B, the rate law for the reaction. And C, the rate constant for the reaction, including units. So we have the reaction of ethanol, CH3CH2OH, in the presence of a catalyst to produce CH3CHO and hydrogen gas. The concentration of ethanol gas over time is used to create the three graphs below. So in one graph we have concentration of ethanol with respect to time, 1 over the concentration of ethanol with respect to time, and the natural log of ethanol with respect to time. All right, so in part A, we're asked to find the order of reaction with respect to ethanol and justify our answer. And so what that does is just mean looking at the graph and figuring out which relationship is linear. That's how we can find the order. So this is the graph that has a linear relationship, and it's concentration of ethanol versus time, okay? And that means that the reaction is zero order for ethanol concentration, since the linear scale on the y-axis yields a line, which means the integrated rate law is of the form concentration of A is equal to the initial concentration minus KT. Sometimes we'll see this as A minus A0 equals minus KT on our equation sheet, right? And this is only the case for a zero order reaction. All right, once we've determined the order in part A, we can write the rate law for the reaction and find the rate constant for the reaction using the graph, including units. So in part A, we determined that this was a zero order reaction, right? And so a zero order reaction, the rate law is just rate is equal to K, which you can see here. Okay, so here's our rate law where rate is equal to K. And then to find the value of K, we find the slope of the line. So when we have a zero order reaction here, the slope of the line, the change in ethanol concentration, or the change in molarity with respect to time, is equal to the negative of K. All right, so that means that K, as you can see here, is the negative slope of the line, change in molarity over change in time. And I just picked at 2,000 seconds and at 0 seconds. So on the graph, I'm taking the point that happens at 2,000 seconds and the point at 0 seconds. Okay, so the concentration at 2,000 seconds is 0.0020 molar minus the concentration at 0 seconds is 0.0100 molar divided by that change in time. Take the negative of it and we get a K value that's 4 times 10 to the minus 6th, and it's molarity per second. 4 times 10 to the minus 6 molarity per second.